So Steve, can we begin by talking about why is biodiversity important?
Yeah, of course. Biodiversity is linked to nature benefits that we derive from natural resources and nature itself. So I think you could look at it as being, it contributes towards the health and sustainability of the environment. Clearly, there's certain things which we take for granted. Nature has a natural way of purifying our own water. It also acts as a buffer, provides resilience to flooding, storms, regulates disease. It's an important factor clearly in things which we depend on: food production, pollination of crops, maintaining food chains. Also related actually very closely to pharmaceuticals, to medicines, and clearly things like fuel production, fiber production, timber production. There's many, you could say, indirect connections which we have as humans to nature as well, through economic and societal sort of connections, which again we don't normally think of, but are clearly there, from tourism, recreation, linkage to mental health, well-being of people. You could say that biodiversity is crucial for life on land and water, or for everything.
So how is human activity impacting the biodiversity around the world?
Yeah, we'll start off with saying it's very difficult to define and measure, but there's clearly, I think, biodiversity has significantly declined globally and is considered to be an existential threat, now comparable and closely related to climate change. I'll put some figures around this. So the World Economic Forum has reported 60% decline in global wildlife in the last 50 years. But at the same time, human population has doubled. So you can see that whilst one's half, the other one's doubled. The UN estimates that 3/4 of all land and 2/3 of all marine areas that have been affected by mankind, mainly for agricultural purposes. That is sharply accelerated in the last 50 years and disproportionately. And as a result of that, as science improves, we think there's somewhere in the order of 1 million animals, plants and species are at threat of extinction within decades. And that's possibly more than 10% of the different variety of species that we have on the planet. Other numbers here, nearly a third of wetlands, a third of all forests, 85% of all wetlands have been lost in the last 5 decades as well. So we're in a vicious cycle of creating monocultures that are highly dependent on pollinators and exploiting natural resources. And however, that very system is rapidly wiping out those pollinators and those resources. So we're out of stability at the moment. Something needs to change, and I think we're going to start to see governments taking more progressive action. We're going to start to see landowners, which are going to be the target, if you like, and we're starting to see more terms like no net loss, net gain, and I think these will become as iconic, if you like, as net zero is to climate change. And I think they are going to target probably large landowners, typically corporates and agricultural sector. So I think there is the sectors which will be hit first from progressive regulations.
What are some of the biggest impacts of biodiversity decreasing around the world? And do you think that it has enough acknowledgement or the right amount of acknowledgement from the governments around the world?
I think it's been developing and growing over time. We've certainly seen in the past 2 decades, the Sustainable Development Goals for life on land, life in water has become very closely linked and synonymous with biodiversity. We're starting to see governments respond to those international frameworks, to creating legislation, and that's starting to come through. It's still taking time, actually. The European Union has a strategy for 2030. We're seeing UK and other countries have put in primary legislation around planning, so it starts to impact on development, construction development, creating marketplaces to convert or change behaviours of how we manage land in a more sustainable fashion. I think it's a very complicated question, actually, but it takes a long time for ecosystems to develop. We've got to think about how we conserve what we have, how we protect what we have locally. So I don't think it's something which is going to be easy to manage over many countries or at the same time with the same frame.
So you talked about how much biodiversity has been lost in the last 50 years or so. How far away are we from the point of no return?
Who knows? Who knows indeed? That's not something which I think we can answer. I think what we are starting to see is that in countries like the UK, where they're densely populated, been converting land for centuries, quite frankly. We adapt and we change, but it's then when you extrapolate out from relatively small parts of the world to such vast areas of the world that we can get a doomsday scenario. You get into a vicious cycle where biodiversity collapses, it collapses, food production then has a direct impact on the human migration and where people will live and can sustain life and where they'll move to. It is a very impossible question to answer as to how we'll respond to these kind of challenges as humanity. But we need to start thinking about how we are being effectively overly aggressive with the way in which we're using land right now in a way which just isn't compatible with nature.
So for the compensation of the loss of biodiversity, as we expand, as we construct, can we compensate for the loss in one place by increasing biodiversity elsewhere? Or do we really need to compensate the loss locally?
It's possibly, that's a great question, actually. So I think that the very basis of biodiversity takes a long time to establish, to mature. In certain areas, they're probably well protected already, where they're niche or very rich, diverse ecosystems. But if we assume that we're not talking about those areas that are protected, then I think the general theme is if you remove a habitat from development, we ought to try and minimize, first of all, the impact on that land through that development process. And then we should really try and restore, recultivate within the same location. Because that ecosystem has taken that time to establish in that area, it clearly works. So it's probably a type of ecosystem that is well suited to that region of the world. So you could say that recultivate the same location which will support indigenous species. In some cases, they're connected ecosystems, so you need that kind of connectivity to help migration of the diverse species to maintain their gene pool. So you've got that kind of connection piece, which is very important locally as well. So restore, rebuild in the same location is preferable to a more of a compensation somewhere else approach, an offset approach. In some cases, clearly it's not going to be possible to restore to the same level. So I think the kind of thought process, the guidelines here are no net loss will be do what you can do locally where you can't compensate locally. Then you should be looking at something close by, redevelop on site, and develop in close proximity, and then finally start to look at things where you can compensate somewhere else nationally is the kind of the general thought process around how best to manage no net loss.
So apart from the loss of biodiversity, another phenomenon we've been experiencing is climate change, and the rate of change has been increasing over the last decade or so. So how are the two phenomena related, the climate change as well as the loss of biodiversity? And can the climate change increase the loss of biodiversity? Also, another question I have is, can increased loss of biodiversity further contribute to the climate change?
Sure, that is. So for sure, climate change and biodiversity are interrelated, both land and water. They have a reinforcing impact. Climate change, to an example, if we cut back a woodland and replace it with pastoral land, so using it for cattle grazing, we're going to reduce the habitats which we have in more of a monoculture, kind of a grassland that's been put in place. We're also reducing carbon on land, the stocks and the absorption rates, which contribute towards greenhouse gases and the level of greenhouse gases. So instead of having something which removes carbon, we're probably changing to a land use which contributes to climate change. And remember, those changes in condition can have a dramatic impact on the existing ecosystem that have taken decades and longer to establish and become fully mature. So I guess the most obvious thing that we can see in this case is bleaching of coral reefs driven by periods of increased water temperatures. As the reef dies, the entire marine ecosystem around it also collapses. So you could say that biodiversity and climate change are inextricably linked. However, it's not quite as simple as that. We could assume reforestation has a positive impact, more wildlife, less greenhouse gases. So ideally, woodland would be also native to a region, enable existing species to extend their range. If we simply have the same wood stock planted, which are just going to be designed really to remove greenhouse gases, then we may choose things which are faster growing, which have less, and plantations of all the same monoculture of woodland, which is typically what we'd see in a plantation for timber production. But they have less benefit from biodiversity. So it's more about how do we create a more diverse mixed woodland that's going to have that potential for wildlife to also extend and also become and thrive in that space. And I think we start to see that being where you have a mixture of different types of woodland. So you can see that one reinforces the other, but it's a choice. It's a choice of, we could make things really simple and just go for one, climate change, we're going to plant more trees, and it's all going to be the same trees, there we go. Or we could say, actually, we're going to take a mixed approach, which is going to have the benefits to wildlife as well as the benefits to climate change. And we're starting to see that those are actually valued in the markets. So we can see that we're We're certainly seeing voluntary carbon markets. There are a kind of a vanilla kind of carbon offset, which has a price. And then you have a kind of the gold standard approach, and there's equivalents to the gold standard approach with all the markets, which have consideration for the benefits to both communities locally, but also to biodiversity, which attracts a much higher price. And we've certainly observed those prices being almost 3 times as high as the vanilla product. So I think it's recognised that we should be taking up the opportunity to use the land in a way which could do both at the same time.
Interesting. So given the different kind of land types that we are, habitat types that we can have, from woodlands to grasslands, and all the different kind of flora and fauna that would make up those kind of lands or habitat types, how do we really measure the biodiversity? What's the biodiversity unit? What does it mean? And how is that measurement done?
Yeah, so as we said before, the measuring biodiversity is challenging because we don't have a common language of what biodiversity really means. There is no common measure of biodiversity globally, which we do have with carbon, right? So we have which is why climate change and measuring carbon has become much more successful. We have a way of universally accepting or talking about climate change gases as an equivalent in carbon dioxide terms. So whether it's methane or sulfur hexafluoride, we can convert it into what's the equivalent in carbon dioxide. And then we can categorize our own carbon footprints. So it makes it easy for people to understand what is my impact on the environment, because I can relate my gas and electricity consumption to carbon emissions. And so I can understand what I'm responsible for and where can I make a big impact and change in what I do to how I contribute to climate change. And wouldn't it be great if we could do the same with biodiversity, right? That would be the kind of the aim and aspiration of, could we get to a language, a terminology, a methodology which is universally accepted as a measure for biodiversity. But it's not that simple. I think there's millions of different species. How do we account for the abundance and richness of wildlife? So how do we get that measure, metric and method? How do we define the value in a particular place over another place? So I can't say that we know all the metrics. They generally speaking, I tend to think of there's 3 broad types of metric, if you like. There's those which are risk-based approaches, so where we can identify areas of real high abundance and richness of biodiversity. What is the proximity and the impact of my operations or kind of constructional development near those sites? There are mechanisms that are much more related to counting and quantifying particular species which are protected. Is there an area where we can see that the species is in decline? How do you account for those species, and then whatever impact is being developed in that area, nature reserve or a triple SI, special scientific interest? How do we see that is improving? And that is quantified in that way. And then the final one is like a scorecard, a more holistic approach, which tries to strike a balance with how do I assess land or water in a way that is creating a score value, which I can repeat nationally or regionally to help me quantify what is the value of my land today, and then therefore I can measure an improvement by proxy, by an approximation of what that habitat would be doing. And the scorecard approach is, the basis there is that holistic balance and using proxies to strike this balance of a range of factors influencing biodiversity, which creates a common unit, enables planners to assess the start of a process, the end of a process, and how much is, how do you quantify no net loss? It can be done through that scorecard approach. How do we quantify net gain? It's coming into place as a result of being able to have this kind of scoring based system. And it remains, it's got to be pragmatic, simple to collect the data as reference data, and then simple enough to plan against, to verify against. And those approaches seem to be what we would lean ourselves towards, as this is more of a way in which organizations and landowner and developers can really use this sort of science-based approach to tracking development and change and net gain. But it has to be pinned by a genuine enhancement in biodiversity. The science has got to be there. I think the UK government has tried and has an approach to biodiversity which has been in development for a few years now, which has been one of the more progressive scorecard approaches. And the measure and classification of habitats by area So it takes into account the space, it uses existing ecological habitat assessment, it's building upon what already is in place, it's classifying those lands, land types, and then trying to create a score based around the approximate value to biodiversity of that kind of habitat type and its condition and its relation to developments locally as well in terms of the connection to local plans to enhance nature. I think that there's a scorecard approach which is has a lot of potential there to be used across the entire country. That type of approach is likely to be of value in other countries as well. It's certainly a good Kickstarter, enables conversations around conservation units to be traded as offsets or planning authorities to set a price for development. If you fail, then how do you work out what is the failure by how much? How do you quantify that? What is the penalty for a developer? And how do you understand the value of biodiversity in relative terms between one landowner and another? So it enables offsets and compensate, or biobanking, that type of concept. But I imagine if you could use the same thing for everyone, if you could assess your own land using a scorecard approach, which could then be quantified as part of an ESG target. So you can see corporates starting to use this as a means of describing how they improve net gain targets on the land asset. It'd be great if you can see companies saying, what are they doing to reduce carbon by 2030 as part of the climate emergency pledge? But at the same time, wouldn't it be great if we could see those same companies being able to say, I'm going to improve my land by a percentage, like 10%, 20% by 2030 as part of a biodiversity emergency pledge. So I think the two would be a very progressive way of helping sustainability going forward.
So as companies try to move towards that, especially in the UK, as they try and meet the goals, the measurement is going to be really important. If somebody has to measure the biodiversity captured in a woodland, for example, what would the conventional methodology for that measurement, for filling up that scorecard, look as of today?
There's already an existing ecological assessment, environmental survey approach in most countries. So there is some standard professional practices which are documented for assessments, but they tend to involve sending an ecologist to a site. It's quite common for organisations to contract with consultant ecologists rather than have their own in-house capabilities. But let's assume that as you're commissioning a piece of work, part of that assessment will include an assessment of a habitat map, a breakdown of the land types, the classification, conditions of those parcels of land. And the process can be require quite a lot of preparation. So in the UK, that would involve the ecologist probably looking at public records, any GIS data sets that can get aerial imagery. It would look at just getting an aerial shot from a data set, a map or a photograph of the region, any historic information that they have from local record centres. And then they've got to get clear the permissions to access the land and safety assessments undertaken beforehand. If they need someone to give them access or not give them access to the site, it's important. And then they typically visit the area, take samples of different spots to qualify what is the region mix, really verify the type of habitat type and the condition of the asset at the same time. So at the final stage, then you bring it back and you document that, you report that, the verification is undertaken by the ecologist, probably with another ecologist, to reassess is there sufficient evidence to ensure that the boundaries and the habitats themselves are correct, and then it gets submitted to a client. Now, for smaller sites, that process really can be easy, relatively quick. For larger sites, it would take quite some time to prepare, and we typically observe that there's a lot of detail in subsections of land as well. There's going to be quite extensive documents that the client receives, and it's a snapshot equivalently of the environmental approach at that point in time. So for biodiversity planning across larger estates, this approach is quite problematic actually, because it's very manually intensive. Most countries, certainly in the UK, we just don't have huge numbers of ecologists they can deploy all at the same time to do lots of assessments of land annually. We could normally say that it's several weeks to undertake a survey of 20 to 50 hectares of scale, and that could cost several £1,000s each time. So those become barriers and challenges to undertaking these sort of estate-based assessments. A baseline of an individual site, a couple of 100 hectares to 1,000 hectares, starts to be spread over numerous sites. The cost starts to increase, the time to capture starts to increase. It becomes more prohibitive to that pragmatism of making these scorecards viable for landowners to deploy them. So they then only get used really for construction purposes and development purposes. So the obvious alternative is to rely more on aerial information. We certainly observed that with customers where they say, I want to capture my data in 1 year. I've got 100 plus sites. How do we assess? And quite frankly, when they see the price and the time, then they say there's got to be an alternative approach. I may sacrifice some of the quality, but I want to be able to undertake this quickly and more economically.
But even aerial surveys are not exactly cheap. And if you're doing an aerial survey by flying a plane, you might be increasing biodiversity, capturing carbon, but you're also releasing a few tons of carbon for every flight you're taking. So what are other alternatives to data capture? So cost on the ground surveys is quite high, as well as there are access issues you talked about. So aerial surveys definitely take care of access issues because you're just flying at a height and capturing everything. But they're not exactly cheap themselves, plus they release a ton of carbon. What other alternatives? Do you get images that are as usable as aerial surveys if you use satellites?
Yes, we do. So every data set has its pros and cons. I think you just described some of the disadvantages there of aerial imagery. I guess counter to that, the advantage is you are tasking an aircraft for an image captured on a particular date, and it's typically of a quite high resolution image. Satellites, the thousands of satellites in orbit now capturing Earth observation data all the time, and they will resell that data into the marketplace, which can be acquired much more economically than from tasking either a satellite or an aircraft to take an image. So you've got an abundance of imagery. The resolution is not quite as high. So if we put some numbers around that, then you are looking at free satellite imagery. I'm talking there from the Landsat Sentinel data sets, which are 10-meter resolution. That's in the public domain. Those can be accessed by research agencies. Commercial grade satellites are down to 30 centimeter resolution. So it is really small and much more granular. And then aircraft is 12.5 to 10 centimeter resolution. So they're more high resolution for aircraft than they are for satellites. I should say that within the next 18 months, I think they'll be comparable. Technology doesn't stand still. We're starting to see satellites which are planned in constellations, which will have high resolution. And I'll also start to see different types of sensors coming through. So in short, yes, you can. And I should say as well that the free data sets are very important for a national view, very good from a research perspective, can be utilized very well for natural capital assessments across a region or for a local authority. The 10-meter resolution is outside the normal standard parameters that we would really utilize for ecological assessments. So a normal ecologist would be usually looking at a habitat as being a minimum of 5 meters by 5 meters. Well, that's the block you would say is the average area for the habitat, minimum mapping unit, if you like. If the free data sets in the public domain are at 10 meters, it's too granular to give you the resolution which is comparable with a typical sort of process an ecologist is undertaking. So rely on that. Clearly, if you drop down to 30 centimeter resolution, you are well within that mapping unit. 10 centimeters again, even more. So satellites have come along a long way in the last decade with the data sets that are available. What 10 years ago was experimental in nature, and I would say that the image recognition software which goes with it, which kind of automates the process to an extent, just wasn't robust at the time. The image costs were very high, the resolution was low. What was not possible then is now very viable and very realistic, that we can get a very accurate assessment of land using satellite imagery and aerial imagery with artificial intelligence.
But I think about 10 years ago, the satellite imaging was around 80 meters resolution. And since then, it has now come down to 30 centimeter. And you said 18 months from now, it should be about a 10 centimeter. So there's clearly Moore's law at play, just like we had in the computer processing industry at one point in time. So we'll hopefully continue to see those advancements, and the satellite imaging is going to be as good as, if not better than aerial imaging pretty soon. You also mentioned towards the end, the use of machine learning and AI. So I think that the use of machine learning techniques can be transformational towards the net gain programs. How do you see technology impacting these programs?
Oh, great question. I see as being threefold actually. There's part of this around is it better to use a human or artificial intelligence? And artificial intelligence has come a long way and can assist with an ecological survey. It's there to support, and that type of assessment enables us to do a number of things. But the first part is, if we can use the data to classify land, then the artificial intelligence is doing something which is speeding up a process. It's reducing the cost of having to visit a site to get that information in there to start with. I'm going to start to see that type of technology moving from, can we classify an image and the boundaries of one habitat and where that ends and the next one starts, which is where we're getting very rich levels of data from an image recognition habitat assessment versus a human, which we find very difficult to clearly mark out where the end point is of a boundary of a habitat versus the next. So getting a very rich and detailed understanding of the area of a habitat is something which image recognition software is very good at. And it's also, that technology is continuously advancing, continuously moving on. So we can start to see that the data sets we can throw at an artificial intelligence can start to help us understand more than just classification. We can start to get into condition and the health of those vegetation assets as well. So we can do a lot using this type of approach, but the main key advantage is consistency, repeatability. I've never seen two ecologists, no matter how professional they are, come up with exactly the same map of the same ecosystem at the same point in time. They just won't. It's professional judgment. It is based upon a series of sample techniques and information which they've been able to obtain. A computer system doing that over and over again on the same land is going to come up with the same repeatable answer. So it's more useful if you want a consistent approach across different parts of an estate.
Especially when you want to apply it to a very large land mass.
That's right. So it can
at,
just be
at scale, at speed.
That's right. So I think, let's be clear about this. I think if you want to do an ecological assessment of one site and it's relatively small, then it's an ecologist. If you want to do something which is much larger, where it's more complex, then you probably need to automate part of that process a little bit with an image recognition software. The second part is data quality. We've set what was 80 meters to 10 meters to 30 centimeters today with satellite imagery. 10 centimeters is in the near horizon. It's not just resolution, it's wavelengths as well. And we're getting into how do we move from just optical data sets into more sophisticated sensor information, near infrared bands. And we break them apart into individual wavelengths. And if you can do an assessment on a hyperspectral banding, which is 300 separate images, then you can start to get a digital fingerprint of a species of a particular asset, a tree or type of vegetation. So detecting things within a minimum mapping unit becomes much more viable as well, which is, again, over a large area. The ecologist is going to take a sample and be able to identify, can I see certain species present, whereas the artificial intelligence will be able to do the entire area. And again, using that type of digital fingerprint and be able to quantify how many. So that becomes very exciting in terms of the capabilities on the horizon of what is plausible. Final technology which is missing in all of this actually is, we've talked about doing the assessment, but the next part is what do you do with the data once you've got the assessment? And that becomes the next challenge really, because most clients look at this as, how do I do an entire estate? How do I do a large project, a scheme, a large area of land? But that's just the first part of a problem. The real problem is this is usually being done for planning purposes, being done for monitoring and program change or planning consenting. So there's got to be a plan as to what I'm going to change the land from and to something different. So how quickly can I generate that plan? And then second to that, what do I do with the data once I've got it? How do we said those reports that we used to get from ecologists, 50, 70-page reports, and in the appendix somewhere would be the table of results that said this is the map and the habitat data, which is now almost the summary of information you need for biodiversity net gain up front. And the other 50 pages can get relegated to being the appendices now, because that's the evidence of how you've derived that habitat information. What do you do with them? Where's that information stored? And I think we've all been in those organizations where somebody said, can we pull back that report we had done 2 years ago on a site? And we can't find it. It's buried away in a shared area somewhere. There's no sort of central repository of that information. And that's missing. So I think if we're doing this from a state, doing it as a baseline of information, it needs to be put into a system of record, which is managed. And that's where software comes back in. So we digitize the process, get away from managing these things as individual reports, and start using the data as what it is, which is a record at that point in time of that location. And then we can use that as a planning base. We can start to store plans. We can start to verify that plans have actually been completed. And that data set never disappears, it becomes a system. So that package, that solution, if you like, digital reporting mechanisms, that third technology, which is just a gap in the market right now, it just doesn't exist. And that's something which is very exciting to be something we can create.
Yeah, the value that the technology is not just limited to the measurement, but right, being that system of record and providing the ability to go back, not just being able to look at what we've done in the past, but an active comparison. The true measurement comes in when you can see what progress you made, and that can help you determine whether your plans are moving ahead, are you on track or not. All of that can be automated as well.
Yeah, that's true. I imagine a world where a company owns a record system of the environmental position on land, their assets, which they have. And they can go back in time. If they started this year, in 2 years' time, they'll have a record each year of what they've done, how they've changed that land, what the value has been, which they can rely upon. And that's very important. To think about it as we're starting to see that change in how information is reported to investors. And so this kind of migrates from something which has been created for ecological conservation and planning and construction purposes into something which every corporate needs as part of a integrated annual report, which includes the ESG scorecard. And I'm hoping we end up with something which is, well, how do you account for no net loss and net gain as one of the key metrics alongside climate change and net zero? And if that happens, then you need a system which is auditable, that can be all the evidence is substantiated and always retained. And it's easy to check back as to what decisions was made, justify the projects, the schemes that companies have made, all the way through to then how do you monitor and verify the benefits that you've invested in, and how have you reported those to part of your own reporting accounts.
What do you find? Are you finding that companies are taking note of this? They're starting to adopt more technology in their biodiversity net gain programs, or is it limited to specific industries and domains, and the rest of the industries are still further behind in the curve?
It's very early days, even in the UK, where we have legislation indicating biodiversity net gain, which will be implemented in full by the end of 2023. So we're starting to see those early adopters start to understand how do we take the surveys, the screening of the surveys, probably in small niche areas of land actually to start with. And there's always a reticence to use new technologies, even though we can intuitively get the head around this makes sense from an economic and scale perspective. I think as it becomes more prevalent and as we get closer to the date when the legislation really kicks in, then I'm sure that we'll start to see more companies asking for what can be done here. How do we maintain records? How do we calculate accurately? That type of scorecard approach, which is used in the UK through biodiversity net gain calculations. So right now we are seeing that there are landowners which are looking for how can they deliver net gain and trade it into the marketplace. We're seeing local councils, local governments, which are looking at how do we retain information, how do we manage information, how do we take stock of our existing areas of interest, and then how do we verify plans when they come in from construction providers. A lot of interest from various different sectors, but as you can imagine, agriculture, construction, some large key utility infrastructure providers and government organisations are all interested in biodiversity and carbon, and many of the metrics, actually natural capital metrics on top of biodiversity to support decision-making processes which they have internally. And I think they all face the same challenge as to how do we undertake a large-scale assessment, or how do we undertake a verification exercise as part of this plan. So I think there's very much an interest, intrigue, a desire to use remote sensing in this way. There's still a part of that which is, do I trust the information I'm getting back? Do I trust the technology is right? So I think there's a little bit of a journey to go on to prove that technology is as robust as we say it is.
But the timeline for the regulation to be adopted by the local councils is end of next year. So it's almost about 15 months away. So if most of the people are still waiting, it might be a little too late for that. So do you think there's going to be some fight in the beginning, some relaxation time, some time for companies to catch up?
I don't think there'd be any respite in that. I think there would be an over-reliance initially on manual processing and manual surveys. And remember, that particular legislation is geared initially towards development and planning consent rules. So we would expect that to be done by existing processes. It's as it starts to expand into how do you verify plans, which if I deliver a scheme in 2023 or 2024, then I prove it's actually been delivered in 2026. And so this becomes something which is exponential in terms of verification of those records to see has the intended habitat which had been created or restored, conserved in some way, achieved. How do we undertake that assessment? And I think as we start to see this broadening out to larger areas and larger schemes, then the need for different technologies will come along as well. And I think there's also, we're probably in that space of what was not viable 10 years ago, and those which have looked at it back then probably also need to be reconvinced that it is now possible. So there is that if we see something and we've worked on something where we've said it probably doesn't work out, then that's probably, as humans, we start to think that can't be done, whereas technology moves on, and it moves on at an accelerated pace here. So I think there's a bit of convincing work that needs to be achieved around how viable is a solution for remote sensing for, say, condition assessment, which can be achieved as well. So I think it's something which is the beginning of a journey, but it is that starting point. But I think it's something which can be add a lot of value and speed things up and accelerate it. And the pressure which will be on investors asking companies to report their impact and sustainability of land and water. And as that starts to come into place, then I think we'll move away from something which is a legislative requirement for planning and consenting to how do you assess your ESG report, your environmental scorecard for land and water annually. And that really does take us into a whole new area, which is no longer countrywide, it's global. And how do you apply a universal metric to an organization which deploys assets in multiple parts of the world?
True. Yeah, I think the conversation on ESG reporting and especially automating the E part of the ESG reporting we can keep that as the next topic. But thank you, Steve. Thank you very much.